Good morning, student. Today we are going to start a new practical, that is VLSI Lab. So today we will do our first experiment of this lab. What is that? So this one is the aim of the experiment. Develop VHDL test bench code for testing different types of gates. So here we will do AND gate, NAND gate, OR gate, NOR gate and XOR gate. Next is the equipment required. For software, we need Xilinx ISC software, or we use this software for our experiment. That is, other softwares are also present to do the VHDL coding, but here we use Xilinx ISC software. Then in hardware we require personal computers. Next, now we will discuss the theory part of this experiment. So here we discuss about 5 gates, 5 basic gates. So first one is the AND gate. The AND gate is an electronic circuit that gives a high output only if all its inputs are high. So here we can observe that in the truth table. So A into B. B. Here a dot operation represents the AND operation. So AND means multiplication. So when we multiply 0 into 0, at the output we get 0. Then 0 and 1, then output will be 0. Then 1 and 0, then output will be 0. Only in the last combination we get a output which is high, means 1. So this is the AND gate. Next is the OR gate. The OR gate is an electronic circuit that gives a high output if one or more of its inputs are high. Means in this truth table you can observe in last 3 combinations, 3 input combinations, means last 3 input combination contains 1 or more ones. Because of that, at the output we get high, means 1, and for only one input combination we get 0. Next is the NAND gate. This is a NOT AND gate, means it is a combination of AND NOT gate, which is equal to an AND gate followed by a NOT gate. The output of all NAND gates are high if any of the input are low, and the symbol is an AND gate with a small circle. So here is the difference that present between the AND gate and NAND gate, only a circle on the output. Okay, so here in the truth table you can see when input is 0 0 we get output 1, when input is 0 1 then we get 1, when input is 1 and 0 then output is 1, when input is 1 and 1 then output will be 0. So it is just the opposite of AND gate. Next is the NOR gate. This is a NOT OR gate, which is equal to an OR gate followed by a NOT gate. The outputs of all NOR gates are low if any of the inputs are high. So when the input combination is 0 0 we get 1, when the input combination is 0 1 then we get 0, when the input combination is 1 and 0, then we get 0, and when the input combination is 1 and 1, then we get 0. The symbol is an OR gate with a small circle on the output. The small circle represents inversion. Then last one, the XOR gate or exclusive OR gate. It is a circuit which will give a high output if either but not both of its two inputs are high. Means when the input combination is 0 and 1 or 1 and 0, then only we get a high output. In other two combinations we get a low output, means that is 0 and 0 or 1 and 0. And this one is the symbol of XOR gate. An encircled plus sign is used to show the XOR operation, that is like this. So this is the theory part of gates. Next, let's do the experiment. Let's start the experiment for gates. For this, first we have to open the software ISC design, then go to the file and create a new project. Give any name for your project. I am giving here SKDAV. Next, then again next, finish. So after that, create a new source. So click here, then select on VHDL module. Then give a name as per your experiment, that is gates. Then next, give the input name for your gate. Let's take A and B for input, and for output we are doing here 5 gates. So 5 output you have to give, that is P, Q, R, S, T, and change the direction, that is out to out. Next, then finish. Then declare the, write down the functions. Okay, first AND gate, A and B. Then assignment operator A or B. Then assignment operator A NAND B. Then A NOR B. Then assignment operator A XOR B. Okay, so the program is complete now. See the program, this library part. We always start the code by including needed libraries and importing the necessary packages from them using the use clause. Okay, this one is the use clause. Then the entity part, we define the entity where we define the input and output ports of our design. Then architecture part, we write an architecture for the above entity. Inside the architecture we define the functionality of our design. Then click here on implementation, then check the syntax. See here, one red cross is showing. That means there is a error present in this programming. So let's try to find it. This one. Here we have to give a semicolon, but here by chance I give a colon. Okay, so change it to colon. Then save it and again check syntax. See here, a green tick is showing. That means there is no error in this program. Then change the selection to simulation. Then again go to new source, select VHDL test bench. Here give a name gates underscore TB, means test bench programming. Then next gates, next finish. Then just remove this programming because we have to change a lot of things. So already prepared programming I take here and paste here. So here you can see this library part. We start writing the test bench by including the library and using its necessary packages. Then entity, we define a blank entity as a test bench, does not define actual hardware. Then architecture part, before begin, we declare a component and signals in its architecture before begin keyword. Then this UT part, that is unit under test. We have to port map the internal signal and ports to enable the test bench to inject input and read its output. We map signals to ports using a keyword port map. This one, port map. Then STIM process. So we start a process STIM and inside it we inject values to the inputs and wait for some time. Means this wait statement gives some delay to properly observe the output. After that, click on this gates TB, then check the syntax. See here, green tick is showing, that means there is no error present. Then simulate behavioral model. This one is the pointer. Move the pointer to any location and see the respective value here. So when A is 0, B is 1, then the AND gate is 0, OR gate is 1, and NAND gate is 1, NOR gate is 0, and the XOR gate is 1. Perfect. Then again change the pointer to another location. See here, input A, B 0, A, B both are 0. In that condition, the AND gate means P gives the output 0, Q, that is OR gate, gives the output 0, R, that is NAND gate, gives the output 1, S NOR gate gives the output 1, and T is the XOR gate that gives the output 0. So it works perfectly. So this is all about gates, different types of gates. Thank you.